Okay, grade 8. Welcome to the final review, your May June review of ratio and rate. We're going to start here at question 1. Any questions you have difficulty with, you can fast forward to watch that particular question, or if you want, just watch all of them and make sure you did all your work correctly. Either way, you're going to do a little bit of learning. The first question is a true-false question. It says, if there are 5 red marbles and 10 blue marbles, the ratio of red to blue is 5 to 10. Well, this is a true statement. This is true. The ratio of red to blue is indeed 5 to 10. Or we could express it this way, 5 to 10, which is also acceptable. But the problem is right here, percentages. It says 50%. Now this is 50%, but the only problem is this is a part-to-part ratio. And when we have part-to-part ratios, in this case red to blue, we cannot create percentages from part-to-part ratios. We learned that the only one you can actually create percentages from is part-to-whole ratios. And in this case, there are 5 red marbles, which is the part we're looking at, but the whole is 15. There are 15 total marbles, which as a percentage is really 33.3 repeating percent, or a third. So the answer for this question is false. Question 2, gotta get a drink here. It says a rate compares, and I spelled 2 wrong. A rate compares 2 quantities measured in different units. That is a true statement. That's just a definition taken right from your textbook. A ratio, if you remember, compares things that are in the same unit. So for example, that last question on marbles was red to blue marbles. That's a ratio of red to blue. But a rate would compare things like kilometers, or distance, excuse me, and units would be kilometers, but distance, which is one type of unit, compared to time. So in this case, kilometers to hours or minutes or seconds or whatever. Or cost to mass. So we'd have things like dollars per gram, or cost of volume. We'd have cost per, or dollars per milliliter. Okay? So the difference between ratios and rates are the fact that its rates are comparing different units. Question 3 says, if a large coffee is $2.40 for 400 milliliters, this is a better deal than a $2 for 340 milliliter medium coffee. So for the answer to this, we can do it a couple of different ways. The one we really have used a lot of was to compare them in unit rates. So if I put $2.40 per 400 milliliters, I can examine it as a unit rate per 100 milliliters. And we call this a 1 deciliter, right? That's why it's a unit rate. Even though it says 100, and a unit rate is 1, 100 milliliters is really 1. It's 1 deciliter, but we never use deciliters, so we'll just say 100 mils. So to create this unit rate, the easiest way for me to do that would be to divide both terms in my first rate by 4, giving me 60 cents per 100 mils. So the unit rate for that would be expressed like this: 60 cents per 100 mils. This is for the large. The medium is $2 for 340 mils, and there are 2 ways you can do it. Now, for a lot of people, I'm going to do it 2 different ways here. For a lot of people, they want to get 1 milliliter first, and then they want to build it back up to 100 milliliters to compare it with this one up here. So to get to 1, you know you divide by 340, but there's a problem with doing it this way. And the problem is when you take $2 and you divide it by 340, you get a lot less than a penny. You get just over half a penny per milliliter. So if you do it this way, you have to make sure you keep 5 decimal places. So I'm going to keep those 5. And the reason why I say 5 is then you're going to multiply it by 100 to get it being 58.8 cents, or approximately 59 cents per 100 mils. Okay? That's one way to do it. But the easier way to do it would be just to divide both by 3.4. right? So if you divide by 3.4, $2 divided by 3.4 is going to give you this number right here anyway, right? And I save having to do this middle step. So roughly approximately 59 cents per 100 milliliters is the cost for the medium, which means it's false because the medium coffee is actually the better deal, right? It's actually a cent cheaper per 100 mils to buy the medium coffee. So the answer is false. Question 4 says a car traveling at a constant rate of 100 kilometers per hour can travel 60 kilometers in under 35 minutes. The easy way to do this would be, well, one of two ways. You could have made a unit rate and figured out 60 kilometers, what would be the unit rate of this particular in kilometers per hour. But the other way I'm going to use it is proportional reasoning. So I'm going to say 100 kilometers in 1 hour is proportionate to 60 kilometers in how many minutes? So I'm going to put X down here, okay? Now, because I have hours over here and minutes over here, I want to change this one here. I'm going to change it to 60 minutes, okay? So if a car traveling 100 kilometers in 60 minutes is proportional to traveling 60 kilometers in how many minutes? So we're using proportional reasoning. So if I create my algebraic equation, I'd have 100x equals the product of these two, which is 3,600. Divide both sides by 100, and I have x equals 36. So I'm going to put 36 here. Okay? And then I'm going to re-examine what it actually means. So if it goes 100 kilometers in 60 minutes, then proportionally speaking, it should travel 60 kilometers in 36 minutes. And the question says it can travel 60 kilometers in under 35 minutes, which is false because it's going to take 36 minutes to do it. Okay? So your answer for that one is false. And there are other ways to do it. I just find using proportional reasoning to be the easiest to kind of understand. It's easiest to set up, and once you get good at it, you can use it for a lot of different applications. Question 5 says, true or false, 60 cents per 100 grams is an example of a unit rate. This is a true statement. Even though unit rate, again, as we said in the last question, means 1, right? 100 grams is really a hectogram, right? Because if you think about the metric system, if I do my little, we got milli, we got centi, we got deci, and we got your unit rate, so whatever the unit is. Then we got deca, then hecta, then kilo, okay? So we think about a gram, which is your unit, right? 100 grams is equal to 10 decagrams, which is equal to 1 hectogram, which is equal to 0.1 kilograms, and so on and so forth. So I know we've never used these units before, so when we talk about 100 grams, we're really talking about 1 hectogram, but we'll never use that. We'll just say 100 grams, and it is a unit rate. Question 6. So question 6 says 60 cans for $12.80, and it says is equal to 50 cans for $14.08 is an example of a proportion. Well, that's true because we learned that when we deal with comparisons, instead of saying equal, we could say they're proportionate to each other, and this would be an example of a proportion. Okay, and I could break it down to a unit rate. I could see how much it is, how many cans you can get for $1, or I could flip it upside down and figure out how much it costs for a can. But it is an example of a proportion. Question 7 said, which is the better deal? A small for 100, a small ice cream for $2.10, a medium for $2.80, or a large for $3.50? For this question, we're going to create unit rates for each of them and see what we get. So for the first one, I'm going to put my cost per grams. $2.10 for 120 grams would be how much for 100 grams? I'm going to compare them by 100 grams, or as we just said in the last question, hectograms. I'm going to divide by 1.2 to create that. Divide by 1.2. So $2.10 divided by 1.2 is $1.75 per 100 grams. For the next one, I'm going to set it up as 280 for 180 grams. How much is that per 100 grams? I'm going to divide by 1.8. Divide by 1.8. Pull up my calculator. $2.80 divided by 1.8 equals, it's $1.56 approximately for 100 grams. And the large would be 350 for 240 grams. Divide by 2.4, divide by 2.4. 350 or $3.50 divided by 2.4 gives you a unit rate of $1.46 approximately per 100 grams. So your best deal is the large. The large is the better deal by, well, not a significant amount, but roughly, what would that be, 10%? Roughly 10% better than the medium, right? But regardless, large is your best deal. Question 8 says, Donnie traveled 2.5 kilometers in 5 hours, and Danny traveled 3 kilometers in 360 minutes. Who traveled at the fastest rate? Well, really, 2.5 kilometers is not that far. It's not even the length of Granville Street. So it's basically like walking from SIS to probably Superstore. And it took him 5 hours. So I'd say Donnie was probably traversing through pretty thick wilderness. But what we're going to do is we're going to create the actual unit rate in kilometers per hour. Okay? So Donnie was going 2.5 kilometers in 5 hours, which is his rate of speed. And the unit rate would be per 1 hour, or per hour, divide by 5, divide by 5. He's going a half a kilometer per hour. Okay? Danny, on the other hand, this is Donnie. Danny is going 3 kilometers. And for this question, it says 360 minutes. Now, since we're looking in per hour down here, I'm going to make a little conversion and say how many hours is 360 minutes. That is actually 6 hours. So when I divide by 6 and divide by 6, I get 0.5 kilometers per hour, which is the exact same rate of speed that Danny was traveling. So the answer is C. They are both traveling at the same rate. Okay, question 9 is no longer true and false. We're now into just solving. It says, if a recipe for cookies calls for a ratio of 1.5 eggs for every 2 cups of flour, then how much flour would you use for 4 eggs? So what I'm going to do is I'm going to set up this using proportional reasoning. And I'm going to get rid of that fraction because I hate fractions. So I'm going to put a ratio of 1.5 eggs to 2 cups of flour is proportional to, I don't know how much flour, but I know I'm going to be using 4 eggs. Okay? 4 eggs for I don't know how much flour. So when I solve this, I'm going to create that algebraic equation. First thing I'm going to do is multiply this way to get 1.5x is proportionate to multiply the other way to get the other side, 8. Divide both sides by 1.5. And you find out that x equals 12. No, sorry, 5.3. Is that right? Did I get that right? I better check that again. 8 divided by 1.5. Oh, yes, I guess it is. 5.3. So roughly 5.3 repeating, which means you need 5 1/3 cups of flour. Because that 0.3 repeating is actually a third. Question 10, if Joe can run 320 steps in 8 minutes, How many steps can he take in 9 minutes? Well, we could do it using proportional reasoning, or we can do unit rate. I'm going to do both. So 320 steps in 8 minutes would give us a unit rate, meaning per minute, of 40 steps a minute, which I can then reconstitute back into 9 minutes by multiplying by 9, and I get 360 steps in 9 minutes. Okay, that's one way to do it. If I use proportional reasoning, 320 in 8 minutes is proportional to how many steps in 9 minutes. When I set it up like this, I can multiply across here to get 8x equals 270 and 180. Oh, hang on, I need a calculator. 320 times 9 is 2,880. Divide that by 8, and x will equal 360. Okay? Or the number of steps would be 360 steps in 9 minutes. Question 11. Okay, so if donuts cost $8.40 for a dozen donuts, how much is one donut? This is actually quite an easy question. We're just looking for a unit rate. So the only problem is a dozen has to be translated into 12. And per one donut, it's simply dividing both by 12 to create the unit rate. And when you take $8.40 and divide it between the 12 donuts, each donut will cost you $0.7, which some people think is 7 cents, but it's actually 70 cents when I put my insignificant zero down per one donut. So it's 70 cents a donut. Question 12 says a sprinter can run 100 meters in 12 seconds. At this constant rate of speed, how long will it take him to run 1.5 kilometers? So 100 meters in 12 seconds is going to be proportional to 1,500 meters. I can't use kilometers in, I'm not sure how long it's going to take. So here, I know I'm multiplying by 15. So I can multiply the bottom by 15 as well. And if I take 12 seconds and multiply it by 15, I get 180. And since it says in minutes, I now have to say 180 seconds is how many minutes. Since there are 60 seconds in a minute, if I go 180 divided by 60, I will find out it's exactly 3, which means it's 3 minutes to travel 1.5 kilometers. If a sprinter was able to maintain that speed, but he can't. Question 13 says using proportional reasoning. Okay, for question 13, it says using proportional reason. Oh, I think I'm on the wrong question. I think I'm supposed to go back a question. I'll go back one. Oh, I think I skipped a question. Oh, maybe I didn't. I think I'm okay. So a penguin can eat 20 fish in an hour. So I'm going to put fish to time. I'm going to write that down so I can keep my numbers square where I have to put them. So 20 fish in 1 hour. In 1 hour. How many fish can he eat in 36 minutes? Now, what's the first thing I should probably do? First thing I should probably do, since I have hours and minutes as my 2 units, I should probably convert one of them to the other. So the easiest way for me to do that is to change 1 hour to 60 minutes. So now that we have it set up as a proportion, the algebraic equation we can create is 60x equals 720. Divide both sides by 60, and you get x equals 12? 12. So because x equals 12, that means that approximately that penguin can eat 12 fish in 36 minutes. How many of you use proportional reasoning for that one? How many tried to use a unit rate? How much? Okay. Both work. Both will work. But as you can see from this example here, the simplest method to use is the proportional reasoning, right? If you get used to setting it up as a proportion and you get used to creating this algebraic equation, then it becomes really easy to solve it, because especially when there's fractions, if you round answers in proportional in unit rate, then you get the wrong answer at the end because you rounded somewhere in there if it's repeating decimal. So try and keep proportional reasoning. Question 14 says the shadow is proportional to an object. So this is the tree that is 12 meters. This is its shadow. This is a good-looking teacher, and this is its shadow. So when I set it up, I want to keep my numbers straight, so I put object to shadow. 12 meters to its 5-meter shadow is proportional to 1.87 to the length of the I don't know shadow. When you work it all out, you'll get an equation 12x equals, what's 1.87 times 5? I'll grab a calculator, don't worry about it. 1.87 times 5, is 93.5. Oh, 9.35? Oh, yeah, 9.35. And when you divide them by 12, the length of the shadow will be 0.78 or 9? 8. Which means, since it says in centimeters, it will be 78 centimeters long. Now, if you put 0.78, obviously you just kept it as meters, right? But 0.78 or decimal 78 meters is 78 centimeters. Still right, yeah, of course, yeah. If you put this number here, you just didn't convert it to centimeters. Question 15. Blank for 1 month is equal to 24,660 per year. How many just divided 2460 by 12? Right, because if you think about this, and I'm going to put it on the other side, if I just take it off here and put it over there, I know that since this is 12 months, dividing it by 12 will get me my 1 month. Dividing this by 12 will get me my missing value. And when you divide 2460 by 12, you get $2.05. Is that right? $2.05. 2460 divided by 12. Question 16. 120 beats in 1 minute 40 seconds equals how many beats in 2 minutes? How many converted both time units just to straight up seconds? How many did straight up seconds? So if I do this, I'm going to put 120 beats in, that's 60 seconds, plus another 40 seconds. How many seconds total? 100 seconds is proportional to, I don't know how many beats in what number goes here? Not 2, 120. Does everyone agree? Yeah? So when I create my equations, it could be 100x equals 14400. Divide, no, 2 zeros. Divide both sides by 100. X equals 144, right? So therefore, if it's 120 beats in a minute 40 seconds, it's 144 beats in 2 minutes. How many had that right, just out of curiosity? You had 100? 171, okay. Do you know what you did wrong? Not sure? Okay. Last question says, or second last question. If you were to buy U.S. money at the bank, Canadian to U.S. is what I'm going to start with. Okay. $100 Canadian would be 73.25 U.S. Okay. So if this is proportional, $100 U.S. will go down here, and I want to know how much Canadian it'll be. So if I set it up using proportional reasoning, $100 Canadian to 73.25 US is proportional to, I don't know how much Canadian dollars it is, to $100. Okay? My equation will be 73.25 x equals 1 with 4 zeros, 10,000, Divide both sides by 73.25 to solve for your x. X will equal, take my calculator, 10,000 divided by 73.25 is $136.52. It says round your answer to the nearest cent. How many had that one right? How many had it wrong but now realized that it would have been easy to set it up like that proportion? You didn't answer it? Okay. A lot of people skipped this one. And the last question, question 18, says if water flowing from a tap flows at a rate of 800 milliliters in 1 minute, how much water will flow in 1 day? So, volume to time. 800 milliliters in 1 minute equals how many milliliters per day? So the question is, how many minutes are in a day? How many minutes in an hour? So if I get it to an hour first, correct. So to get it per hour, multiply by 60, and then multiply it by 24. 48,000 multiplied by 24 equals 115200 over 1 day. But is that milliliters? Now, Emma, how many milliliters in a liter? How many milliliters in a liter? 1,000. So if I knock off 3 zeros here, it would be 1,152 liters of water a day. Okay? 1,152 liters. Okay.